It is not permissible to have a water or drain system directly above an electrical room, nor is it acceptable to use a pan under a drain or water line in such a location. The primary reason for this prohibition is the inherent risk associated with water intrusion into electrical systems. Water is a conductive medium and can create a pathway for electricity to flow where it is not intended, leading to a variety of hazardous conditions. Firstly, water leaks or spills can come into direct contact with electrical wiring or equipment. This contact can cause electrical shorts, where electricity bypasses its intended circuit and flows through the water instead. This short circuit can generate a significant amount of heat, which can ignite flammable materials in the vicinity, leading to a fire. Secondly, water can corrode electrical components such as wires, connectors, and equipment enclosures. Corrosion can degrade the insulation of wires, making them more susceptible to shorts and ground faults. It can also weaken the structural integrity of equipment, making it more likely to fail under stress. Thirdly, even small amounts of water can create a shock hazard. If a person comes into contact with water that is energized, they can receive a severe or even fatal electrical shock. This is particularly dangerous in electrical rooms, where there may be exposed conductors or equipment. For these safety reasons, it is imperative to maintain a separation between water and drain systems and electrical rooms and equipment. If it is absolutely necessary to have a drain or water line in close proximity to an electrical room, several precautions must be taken. Firstly, the drain or water line should be constructed of durable, non-corrosive materials such as copper or plastic. Secondly, the line should be properly sealed and insulated to prevent leaks or condensation. All joints and connections should be tightly sealed to prevent water from escaping. Insulation can help to prevent condensation from forming on the outside of the pipe, which can also lead to water damage. Thirdly, a drip pan or other containment device should be installed beneath the line to catch any leaks that may occur. The drip pan should be made of a non-conductive material and should be large enough to contain any potential leaks. It should also be equipped with a drain to allow for the removal of any collected water. Fourthly, the electrical room should be equipped with a ground fault circuit interrupter, or GFCI, to protect against electrical shock. A GFCI is a device that detects small changes in current and automatically shuts off the power if a ground fault is detected. This can help to prevent serious injury or death in the event of a water leak. Fifthly, regular inspections should be conducted to check for any signs of leaks or water damage. These inspections should be performed by a qualified electrician or plumber. Any leaks or water damage should be repaired immediately. It is also important to ensure that the electrical room is properly ventilated to prevent the buildup of moisture. Moisture can condense on electrical equipment, leading to corrosion and other problems. Proper ventilation can help to keep the room dry and prevent these problems. In addition to these precautions, it is also important to follow all applicable building codes and regulations. These codes and regulations are designed to ensure the safety of buildings and their occupants. They may specify additional requirements for the installation of water and drain systems near electrical rooms. The National Electrical Code, or NEC, provides specific guidelines for electrical installations, including those in areas where water may be present. It is crucial to consult the NEC and any local codes to ensure compliance. Furthermore, it is essential to educate personnel who work in or around electrical rooms about the hazards of water and electricity. They should be trained to recognize the signs of a water leak and to take appropriate action to prevent electrical shock or fire. This training should include information on the proper use of GFCI devices and other safety equipment. In summary, while it may be technically possible to install a water or drain system near an electrical room, it is generally not recommended due to the inherent safety risks. If such an installation is unavoidable, it is crucial to take all necessary precautions to prevent water leaks and to protect against electrical shock and fire. This includes using durable materials, properly sealing and insulating the lines, installing a drip pan, using a GFCI, conducting regular inspections, and educating personnel. Failure to take these precautions can result in serious injury, property damage, or even death. Remember that electrical safety should always be a top priority. If you are unsure about any aspect of electrical safety, consult a qualified electrician. Their expertise can help you to identify and mitigate potential hazards and to ensure that your electrical systems are safe and compliant with all applicable codes and regulations. Consider the implications of potential condensation as well. Even if a water line is not actively leaking, condensation can form on the outside of the pipe, especially in humid environments. This condensation can drip onto electrical equipment and cause damage. To prevent condensation, the water line should be insulated with a vapor barrier. The vapor barrier will prevent moisture from reaching the pipe and condensing on its surface. The type of insulation used should be appropriate for the environment in which it is installed. In humid environments, a closed-cell insulation is recommended. This type of insulation is more resistant to moisture and will provide better protection against condensation. Also, consider the potential for future modifications or repairs. If the water line ever needs to be repaired or modified, it will be necessary to shut off the water supply to the area. This can disrupt operations and cause inconvenience. To minimize disruption, it is important to install shut-off valves in the water line near the electrical room. These shut-off valves will allow you to isolate the water line and make repairs or modifications without having to shut off the water supply to the entire building. In addition to shut-off valves, it is also important to provide adequate access to the water line for maintenance and repairs. This may involve installing access panels or creating a clear path to the water line. Adequate access will make it easier for plumbers to inspect and repair the water line, which can help to prevent leaks and other problems. The selection of materials for the water and drain system is also critical. Avoid using dissimilar metals in the system, as this can lead to galvanic corrosion. Galvanic corrosion occurs when two different metals are in contact with each other in the presence of an electrolyte, such as water. The electrolyte causes one metal to corrode more quickly than the other. To prevent galvanic corrosion, use the same metal for all components of the water and drain system, or use dielectric fittings to isolate dissimilar metals. Dielectric fittings are designed to prevent the flow of electricity between two different metals. They are typically made of a non-conductive material, such as plastic or rubber. In addition to preventing galvanic corrosion, it is also important to protect the water and drain system from physical damage. This can be accomplished by installing guards or barriers around the system. Guards and barriers will protect the system from impact and other types of damage. They can also help to prevent accidental contact with the system, which can be a safety hazard. Finally, it is important to have a plan in place for dealing with water leaks. This plan should include procedures for identifying and reporting leaks, shutting off the water supply, and cleaning up any water damage. The plan should also include contact information for qualified plumbers and electricians who can provide assistance in the event of a leak. By having a plan in place, you can minimize the damage caused by water leaks and ensure that the problem is resolved quickly and efficiently. Remember, the goal is to create a safe and reliable environment for electrical equipment. By taking the necessary precautions, you can minimize the risks associated with water and drain systems near electrical rooms. If unsure, it is best to consult with qualified professionals and local authorities. Consider the location of the electrical room as well. If the electrical room is located in a basement or other area that is prone to flooding, it is even more important to take precautions to prevent water from entering the room. This may involve installing sump pumps, sealing the walls and floors, and elevating electrical equipment above the floodplain. Sump pumps are designed to remove water from basements and other low-lying areas. They are typically installed in a sump pit, which is a hole in the floor that collects water. The sump pump automatically turns on when the water level in the sump pit reaches a certain level, and it pumps the water out of the basement. Sealing the walls and floors of the electrical room can also help to prevent water from entering the room. This can be accomplished by applying a waterproof sealant to the walls and floors. The sealant will create a barrier that prevents water from seeping through the walls and floors. Elevating electrical equipment above the floodplain is another way to protect it from water damage. This can be accomplished by mounting the equipment on platforms or stands. The platforms or stand should be high enough to keep the equipment above the expected flood level. In addition to these measures, it is also important to have a good drainage system in place around the electrical room. The drainage system should be designed to divert water away from the room. This can be accomplished by grading the ground around the room so that water flows away from the room, and by installing French drains to collect and remove water. French drains are trenches that are filled with gravel and perforated pipe. The gravel allows water to seep into the trench, and the perforated pipe carries the water away from the room. Regular maintenance of the water and drain systems is also essential. This includes inspecting the systems for leaks, corrosion, and other problems. Any problems should be repaired promptly to prevent further damage. Maintenance should also include cleaning the drains to prevent clogs. Clogged drains can cause water to back up and overflow, which can lead to water damage. Consider the impact of humidity on electrical equipment. High humidity can cause corrosion and other problems. To prevent these problems, it is important to control the humidity in the electrical room. This can be accomplished by installing a dehumidifier or an air conditioner. A dehumidifier removes moisture from the air, while an air conditioner cools the air and reduces its humidity. In addition to controlling humidity, it is also important to control the temperature in the electrical room. High temperatures can damage electrical equipment. To prevent this, it is important to provide adequate ventilation in the room. Ventilation can be accomplished by installing fans or vents. Fans circulate the air in the room, while vents allow hot air to escape and cool air to enter. Furthermore, the NEC Article 110.26 addresses working space about electrical equipment. Maintaining adequate clear space is critical for safety and accessibility.